one last example here with counting. We have a deck of cards, and if you're dealt 4 cards out of a shuffled deck of 52, find the probability of getting exactly 3 jacks and 1 queen. Now, it doesn't matter which 3 jacks and which 1 queen you get, we just want that probability. It also doesn't matter what order they come in, right? They can come in any order, jack, queen, jack, jack, or whatever, it doesn't matter. Nor does it matter which order the jacks come in. So order doesn't matter. That means we're doing combinations, not permutations. Okay, so to find the total number of possible hands, that's the denominator. Total number of possible hands. You're taking basically 52, choose 4. That gives you all of the options in the sample space, all the possible 4 card hands. Then you want the number of ways to get 3 jacks. Well, that's going to be 4 jacks, choose 3. There's 4 of them out there, you get 3 of them. The number of ways to get 1 queen, well, there's 4 of them, you choose 1. So 4 choose 1. Now, what's interesting is that to get the total number of ways to get 3 jacks and 1 queen is to multiply. You got 4 choose 3 options for the 3 jacks, 4 choose 1 options for the 1 queen. Multiply them together to get the total number of ways to get both. Okay, that's our fundamental counting principle. So the probability of getting 3 jacks and 1 queen is going to be the number of ways to get the 3 jacks times the number of ways to get the 1 queen all over the number of possible hands. So that is 4 choose 3 times 4 choose 1 all over 52 choose 4. Now each of these can be calculated. Let's see, this is going to be 4 factorial over. Now with these combinations you do the difference, which is 1 factorial times the 3 factorial on the bottom, and then here 4 choose 1 is going to be 4 factorial. You want the difference between them is 3, and then the r, so n and r, so n factorial, the difference factorial, and r factorial. And then on the bottom here, we're going to have 52 factorial over the difference, which is 48 factorial, times 4 factorial. Okay, so again, with the combinations, it's always n factorial, n minus r factorial, and r factorial. And then we just calculate all those things. Now this does get a little bit lengthy, but we can simplify it. There's a lot of stuff to cancel. 4 factorial over 3 factorial is just 4, right? 4 factorial is 4 times 3 factorial, and you divide out the 3 factorial. The 1 factorial is just 1, so that doesn't really play in here. 4 factorial over 3 factorial, 1 factorial, that's also 4, right? 4 times 3 factorial over 3 factorial, and 3 factorials cancel. And then on the bottom, I have 52 factorial over 48 factorial. I can cancel everything from 48 down. So that's going to be, going to be 52 times 51 times 50 times 49, because everything from 48 down cancels. And I also get a 4 factorial, which maybe I'll just write out as 4 times 3 times 2 times 1 on the bottom there. If I do a copy dot flip, that numerator is 16. I'm just kind of running through this. That's 16 on top, and I'm going to multiply that by the reciprocal of this. So that's 4 times 3 times 2. The 1 doesn't really matter, so I'm not going to write it. And then on the bottom, it's 52 times 51 times 50 times 49. If I do a little bit of canceling, What can I cancel here? There's not a ton of canceling to do. The 3 and the 51 cancel, that's 17. The 2 and the 50, that's 25. I could cancel the 4 with the 52. How many times does 4 go to 52? I just lost that one. 13 times? Yeah, 13 to. And there's not really anything else I can cancel that I see. So I'm really left with a probability of 16 over the product of 13 times 17 times 25 times 49. And so I just got to calculate that, whatever that denominator is, 13 times 17 times 25 times 49, which is a big number. So it's 16 out of 270,725. Choose 4. Yeah, that sounds about right. Okay, that's a big number. And then you just take, to get the actual probability, if I wanted that in decimal form, this is a reduced fraction, so this would be sufficient. If I wanted that as a decimal, now that is approximately 0.0000591, and then some other decimals after that. So yeah, so that's like a really small percentage. Okay, so that's the probability of getting 3 jacks and 1 queen out of a 52 card deck. There is a lot of possibilities when you get 52 cards and you just deal 4 of them out. So that's why this is such a small probability. But you can kind of see then how we can combine the combination formula along with the fundamental counting principle to get these products and quotients of this the combinations. So kind of interesting. That gives us our probability.